In this video, we're going to talk about the basics of probability. And we have to define a few terms and principles about probability before we start using it. So in probability, we have something we call the sample space. And this is similar to statistics, but just a little bit different. So with probability, we have a different possible outcomes for individual outcomes. So for example, what I mean by that is, let's say we have this dice or die over here. One dice is a die. So the different possible individual outcomes, or the sample space for this die, is 1, 2, 3, 4, 5, or 6. So these are all the possibilities that we could get out of rolling this die. Okay, that's our sample space. So then, when we talk in probability about an event, this is our collection of outcomes. So for example, rolling a 4. So we would ask, what is the probability of rolling a 4 on our die? And that would be our event in our sample space. The next thing we have to define is theoretical probability. And this is different from experimental probability, which we'll discuss in a future video. But theoretical probability is the number quantifying how likely the event is. And in this case, we have a 1 out of 6, and we usually write it as a fraction, a 1 out of 6 chance of rolling a 4, for example. So those are our basic definitions. Now we also have to define some principles. So for probability, the first principle is if events are equally likely, then their probabilities are equal. So again, back to our die rolling, the probability of rolling 1 is 1 out of 6. And the probability of rolling a 5 is 1 out of 6. These events are equally likely when you're rolling a die, unless your die is weighted, then you're cheating. But if you're rolling just an average die, then these things would be equally likely, and they have the same probability, 1 out of 6 for each one. The second principle is that the probability of an event is the sum of the probabilities of the distinct outcomes that compose that event. So, for example, we could have an event that we define as rolling an even number. Again, we're looking at our die. Even numbers are 2, 4, and 6. So each one of these has a 1 in 6 chance of being rolled. So the probability of rolling an even number is the sum of those, 1 out of 6, 1 out of 6, 1 out of 6, or 3 out of 6, which we can reduce to 1/2. So that's how we calculate probabilities of events that of a sample space in an event, or an outcome set of outcomes in an event. So then, number 3, if an experiment is performed many times, then the fraction of times the event occurs is likely to be close to the event's probability. The greater the number of times the event is performed, the more likely that the fraction of times the event occurs is close to the event's probability. And this gets into something that we will talk about in a future video, but it gets to the difference between theoretical probability and experimental probability. experimental probability, if we're actually rolling the dice or the die, then if we roll it once, we probably, it won't, or if we roll it a small number of times, like 10 times, we might not get the same probabilities that we predict as our theoretical probability. But if we keep rolling it and we roll it 10,000 times, then our probabilities are going to look closer to our theoretical probability. We will, as I said, talk about this more in a future video. So for now, know that these are the principles of probability that we will be working under in this class. One last thing about probability. I said that we represent probabilities as a fraction. And the way we do that is the numerator, or the top number, represents our favorable outcomes, what we want to see happen. And then our denominator, or the bottom number, represents the total outcomes. For example, here we have this bag of marbles. Very cool bag of marbles. And we have some red marbles and we have some blue marbles. So there are 12 total marbles in the bag. 7 of them are red. So our probability, and if you see this P with parentheses, that just means probability of drawing a red marble out of the bag is 7 out of 12. So it's the number of red marbles, our favorable outcomes on the top, and our total number of marbles, the sample space, on the bottom. Likewise, the number of blue marbles here for our second probability is 5 out of the total number of marbles. By the way, in terms of probability, if you add up all the probabilities of events in a sample space, you should come out with 1. So for example, if I add 7/12 plus 5/12, ta-da, I come out with 12/12. So, and that's the same as 1. So your probabilities of each outcome, add them together, and you should get 1 for your sample space. We'll talk about more with probability in the next video.